So we had a good discussion yesterday about ownership of firmware. Does it rest with the person making the company making the machine, or the person who owns the machine? And I think roughly that's what Elaine's talk is going to be about. My argument is IBM really got it right, so here we go.
Thanks. Raise your hand if you can hear me. Yeah, good. Okay. I work at IBM's research division. We have research divisions all over the world, and this particular white paper that I'm talking about was written in cooperation with my colleagues in Zurich. So, what is this about? We have written a white paper about ownership, how to initialize it, how to transfer it. It is available on the OCP website. It's a white paper, really is white paper. You can just print it out. The details, I won't go into the horrible technical details because we don't have time, but I'll do as much as we can. But if you really want the gory details, they're in the paper. In addition to that, we cover multiple groups within OCP. This was written under the, I guess, the hat of the security group, but it also applies to open system firmware and to hardware management. Okay, why did we do this? So we're going to talk about why did we write the paper, what problem were we trying to solve when we came up with our solutions. I'll talk about ownership, how do you initialize it, how do you transfer it to someone else, and then OCP would like me to relate that to their tenets, if we have time. All right, why did we do this? So honestly, we've been working in this for quite some time. Personally, I've worked on a lot of those things on the left with smart cards, hardware security modules, big servers. And we thought everybody else knew how to do this. And then when we got into OCP, we realized, oh, well, I guess they don't really. Maybe we've just gotten all the bruises and scars before everybody else has hit it. So we thought we better kind of share this information. And it really is pretty easy to do it right, so it's not scary. Did that already. Okay, so what are we trying to solve? Ron, I have quoted you here. If you don't own your firmware owns you. There you are, you're famous.
Okay, I'll take it.
Yes. So we're trying to solve these problems. So way over on the left, how do we initialize a device with information about who its owner is, right? We also don't want attackers to become owners of the devices, so we want to prevent that. How do we transfer the ownership from one owner to another, but do it securely? Because if you don't do it securely, then anybody can transfer it, right? What if we don't know who the next owner is? This happens quite a bit in manufacturing and field replaceable units. Who owns those things? You got parts sitting on your shelf, your replacement parts, who do they belong to? Who owns them? All right, so what's an owner? An owner is someone who someone or an organization that controls what firmware is allowed to run on a device. The owner is known by multiple terms in the industry. It's called an authority, an owner, an officer, an administrator. You hear all of those terms when people are talking about owners. And to complicate things, the owner is not necessarily the person who bought the device, and it's not necessarily the entity that is in control of the device physically, nor is the owner the one who holds the intellectual property that's running in the device. It can be, but it's not necessarily. And let's complicate it even further. So a device can have multiple owners over its lifetime, and even simultaneously. So in one of our devices, we have a hardware security module, and it has different layers, right? So the power on self-test might have one owner. the secure boot process of it is a different owner. There's an operating system. In servers, you've got hypervisors, right? And at one point in time, manufacturing owns the device and has to do its manufacturing tests. So, and they, of course, don't want all of that security junk in the way because they've got to debug the things and test them. And, of course, you have applications that run inside these devices. Those owners want to control their applications. So it's not just one owner, right? All right, so let's talk about, there are at least 3 ways to establish ownership. The imprinting is one of those. It's just like the mother duck, right? The baby duckling looks to see who is its mother, and it's the first thing. If it turns out to be an elephant, well, that's its mother, right? So the imprinting style of initialization is where it's first come, first served. Whoever gets the device first gets to initialize it and become the owner. All right, so this hardware technician becomes the owner of the device, and it recognizes his organization as the owner. Now, I'm going to go through 3 of the 3 styles, right? Not any one of the 3 styles is perfect. They all have potential attacks. They all vary depending on what your manufacturing process is. There are lots of variables. So going on the imprinting one, you have combinations of, you've got good credentials from the right organization, but you've got an evil device. Or you might have bad credentials on a good device. So let's talk about a software clone here. So in the software clone, you think about a device that needs to be secure. We can use a hardware security module as an example. In that case, if you as an attacker would love to have a software clone of this hardware security module so that you can trick people into giving you their keys and signing things, doing all kinds of evil things, right? So in the software clone case, what happens is that the owner doesn't realize that you're a software clone, and the owner issues legitimate, honest-to-goodness credentials to malicious software. So you want to avoid that, right? The hardware clone attack is where the real owner is tricked into thinking that it's the honest-to-goodness kind of, honest-to-goodness hardware device, right? And what it is malicious hardware that's been manipulated, attacked. For example, something that's been physically attacked so that you can get at the keys and such inside. But the owner doesn't realize that. And this is a common, for example, a supply chain attack, where a device has gone from the manufacturer. It's not yet initialized, right, because we're using the imprinting model. So it falls off a truck or stolen off of a truck, and then the device is manipulated physically, and then it becomes, it eventually goes to the destination. When it's time to imprint it, the owner doesn't realize it's been physically hacked, and the owner imprints it with the right keys, and now you've got a bad device with good credentials, and you can't tell the difference. All right, the get there first attack is where the attacker, it's much like the hardware clone, but it's where the attacker is the one that gets there first. Not necessarily a hardware attack, but it could be a logical attack. But what happens then is that the owner doesn't realize that the firmware or initialization code inside of this device has been manipulated so that it tricks the owner into issuing it legitimate certificates and credentials, but it really is compromised. And the last one, there are more attacks, they're in the paper, but The last one is where the attacker, in this case, is impersonating the owner, right? And the attacker issues credentials to a device. So in all of the imprinting style of taking ownership, one of the real problems are man-in-the-middle attacks. If you know that your device, I can see that this system is right here in front of me, and if I can directly connect to it, I can imprint it, and I know that and unless it's been modified hardware-wise, I know that that I have become the owner. If I'm trying to do this across the world to some device that I can't see, can't touch, can't do anything with, then how do I know that what I'm trying to imprint it with is really getting there and not being intercepted or changed? So imprinting is very commonly vulnerable to man-in-the-middle attacks unless you have a good secure protocol between the owner and the device. Another style of initialization of these three styles is using transport keys. Transport keys these are very common in the credit card world, smart card world. What happens, and it's very common in IoT devices, where there are a very large number of devices. They move from a manufacturer to another step in the supply chain, and those two parties share a key. And only those two parties know what the key is. And it's initialized, the duck, in this case, the duck says, I'm your temporary mother. And it goes on, is shipped. And when it gets to the other end, the receiver then says, okay, I know that I have this temporary key. I can use it to take ownership and transfer it to me. Of course, you got problems with that one too, right? All right, so if you're the manufacturer and you have to set up this key in 10,000 devices, how many do you make? How many are you going to, if I'm going to sell 10,000 devices to Ron, how do I know, for example, that I should put exactly 10,000? Or what if Ron backs out of the deal? What if I've initialized 10,000 devices and Ron says, nope, I don't need those after all? So then what do you do? Stop selling to Ron. All right. Now, the other problem, this is again a security problem. What if the seller is either not competent or is a bad guy and puts the same device, the same key in other devices too? Well, I, as the buyer, I don't know what he did with this key. I think, Ron and I think that we've shared this key, when in fact I'm just incompetent and I have actually used that shared key with some other customer. Now that other customer has Ron's key because I have shared it, I just didn't do the right thing. So you're reliant on the two parties. What about, again, I'm a seller and I'm put my key on a laptop and my laptop gets hacked. So now Ron is vulnerable because I let somebody get my laptop and get the key. And again, we have this problem. I might know how many I'm selling to Ron now, but I need field stock, right? And I need stock to replace parts in other customers. So how many do I do? Whose keys do I put in those? Who owns them? All right, the third and last style of imprinting is putting in permanent keys at manufacturing. I can see that you're all thinking, that one's better, this one's better, but they're not. Oh. So in this case, the device gets its credentials and its ownership, or at least one of the owners. Remember, it could be applications, operating system, the power on self-test, or whatever it is. At least one of the owners is known before it leaves the factory. And that owner is put into the device. But the owner's public key does have to be protected by hardware. We'll go into that in a minute. The device that I worked on, which has a FIPS 140-2 level 4 certification, uses this model, where before it leaves our manufacturing facility, it has an owner in it at the beginning. All right, we got problems with this one too. So one question is, do I know at least one of the owners? Right, if you know at least one of the owners, you can put that owner in. But then let's talk about another problem, which is, okay, that owner now is the initial owner and has to stay that way, or at least hand over ownership to the next one. In the case of servers, for example, some of our customers don't want us to be the owner. They want to be the owners, right? So if we put our key in at manufacturing, this offends these customers who are quite concerned about security. They don't want us to be in control of their device, right? Another problem is, suppose I put my key in at the factory, and again, in the supply chain, someone attacks it, physically attacks it, and changes the key not to a hacker's key. From that point on, then the hacker owns the device, right? And the hacker can put anything the hacker wants to put in it. So if you don't have a way to protect the owner's key, then you're vulnerable to those kinds of attacks. And then what if the buyer wants to sell it to someone else? So I've sold it to Ron. I still have this ownership thing, even if Ron wants to put his key in. Can Ron then sell it to someone else? What is the transfer possibility for these kinds of devices? And of course, there are different schemes that are even hybrids of those three, where you may have a shared key in one point in the supply chain, and then it switches over to one of the other models. If you, no matter what you do in ownership, there are two absolute minimal requirements. The first is that, now again, I'm using public keys. You can do all of this with shared keys, with symmetric keys, but in general, people use public keys, so I'll use that model. The two requirements are, you've got to remember the owner's public key. Your device has to remember who owns me, so that when digitally signed firmware or upgrades, anything is presented to that device, it can recognize its owner and accept or reject those updates. The second thing is that it has to obviously verify the digital signature of any updates that are coming from the rightful owner. So those are the minimum. Now, if you're a device manufacturer, how can you represent ownership? It would seem to be complicated, but it really isn't at all. You can do this with a tiny amount of persistent memory. These are the fields that you need. You need to know who the current owner is, which could be represented either by a raw key or a certificate. It's helpful to know the previous owner, who is the designated successor owner, and whether or not this ownership transfer is reversible. All of this is in the paper, by the way. The way we have implemented this is with a very simple state machine where you start off with your current state. There's one command that says, I want to change the owner. This command processor then evaluates whether the command was properly signed and whether the state change is allowed. And once there is a state change, then you go back to the beginning and you start all over again. It's a really, really simple state machine that doesn't require a lot of memory. I think I can go through this. So this is one part of this state machine. It's kind of an eye test, but in general, what the state machine has to do is verify the signature on the command, and then decide, well, if it failed, of course, obviously there are failure states. Is there a new owner that's requested? I'm over in the bottom, middle right over there. In the command, was a new owner requested? No. Well, if there's no new owner requested, then go and replace all of the fields in those 4 fields, right? The new owner, the previous owner, the revertibility, and designated successor. Any of those will be replaced or can be replaced in that step. If there is a new owner requested, then you can't just switch it, right? You can't just say, here's your new owner. You have to decide, was there a designated successor? So if Ron is the current owner, and he wants to change ownership, then he sends a command that's digitally signed. He says, this is who the new owner is. But if the device had already been locked or had already been put a designated successor in that Ron could only transfer it to David, then Ron's command will fail unless he's trying to transfer it to David as the designated successor. And essentially, that's it. I mean, there are a few other states, there are a few other conditions, but this is the normal transfer. The state machine is very simple. Using those 4 values and the state machine, some of the handovers that you can accomplish are a cancelable, where I hand it over to a person, but we can cancel our transaction. Some are direct, but we cannot cancel. It's irreversible. We've had problems where we've got to be able to return devices back into inventory where we thought they were being sold, but we had to pull them back again. Some you've got to be able to erase all history of whoever owned it ever. Sometimes you have to cancel a handover that's in progress. Sometimes you don't know who the successor is, so you've got to go through an intermediate step. And sometimes you do know who the successor is, but you still have to go through an intermediate step. I'm going to scare you now, but this is in the... This chart shows pretty much all of the possible transfers that you can imagine. And the green arrow shows just one of the flows. So in this case, we have on the left, we have one owner who's the manufacturer, who's the Republic of Utopia. And the successor owner is the People's Republic of Utopia. So the Republic of Utopia says, okay, I now need to transfer this device. We know that PRU, the People's Republic of Utopia, has bought a number of modules. So it moves from within Utopia to Utopia, like from manufacturing floor, perhaps into the distribution part of the company. And then the distribution part of the company says, okay, I'm now going to move that and make People's Republic the owner. So there are those 4 fields. You see the top one is the current owner. The middle box is the previous owner. The bottom one is the designated successor. And then there's a field as to whether or not you can revert what you just did. Yeah? Okay. So if you, I won't drag you through this, but essentially what you can do is this device can travel through different stages of ownership. And at the very end, the People's Republic has now set up their own factory state for the device, which is where they are the current owner. They have wiped out all history of it ever having been in Utopia. So there's no previous owner, there's no successor, and they can revert. All right, so OCP likes us to relate these concepts to their tenets. In this case, our scheme is it's quite efficient because it doesn't use much storage. The signature verification is probably the biggest part of the code, but it's likely there anyway because you have to verify the signed firmware itself, so you might as well verify the commands too. It's scalable, it runs in tiny little adapters, it runs in big servers, and it can be administered remotely. If you want to, you can keep longer histories, not just the previous owner, but many. It's open, of course. We've got the white paper out there to explain how we did it. And the impact is that we're very much concerned with improving the security of the supply chain. And within that supply chain, devices can manage their own updates, right? Once they have an owner, they can manage it themselves. So this is a plug for our security group in OCP if you want to get involved. One, if you want to sniff it and decide whether you want to do it, you can just check it out. If you want to dig deeper, we've got a project wiki if you want to follow us or if you want to participate. So all levels of possibility there. And that's it.
Do we have a question?
Yes?
Oh, sorry.
Can you touch a little bit upon the reversibility? Isn't there implicit security risk in reversibility?
Yeah, the reversibility is there and is controllable, right? So whoever takes ownership can set that bit. If you do not want reversibility, then you certainly would want to set it so that you can't. Yes, it can be a bad thing if you can reverse, but the device has been initialized and it has user data in it, it has keys, what have you, then you probably wouldn't want to be able to reverse it. Right.
It's a provision that it's optional.
It's optional. Yep, and you control, the owner controls it.
Hey, Elaine. Can you comment on how this might intersect with SP 800-193 from the standpoint of like roots of trust for recovery and the general consensus, at least that I'm seeing, that that implies immutable behavior, right? So if you were going to do a transition, that means your 6K of stuff has to be bigger, right? If you're going to do that in OTP or something like that. Is that kind of how you're thinking about that?
In 193, obviously everything has to be signed, right? It's got to be an authenticated update. I would categorize this as an authenticated update, right? It may not be updating firmware, but you're updating the owner. So it should go under the same scrutiny.
Any other questions? Let's thank our speaker again.